Hey there, good to see you again. We are still in the throes of systems. We talked about systems of linear equations previously. Now we're going to talk about systems of inequalities, both linear and nonlinear. So that's where this lesson's taking us today. First of all, linear inequalities in two variables. You've probably seen them before, but here's a quick rehash of what they look like. If they're in that format, ax plus by is like less than equal to c, or less than, or greater than, or greater than equal to. Basically, they look like equations of lines, except there's an inequality symbol instead of an equal sign. And then when we go to show the solutions, we're still going to be graphing, just like we do with lines. But we've got to pay attention to that inequality sign. The inequality sign is going to tell us whether or not we're going to include the line or the border, or if it's nonlinear, whatever the shape is, parabola, circle, whatever. If you have an equals to, then you're going to use a solid drawing. If you have a no equals to, if it's just less than or greater than, you're going to use a dash drawing to show that the border is not included. Solid, the border is included. Dash, the border is not included. And then you're going to have to do some shading. You're going to have to figure out which side of your border, which side of your graph you just drew, has all the answers for the less than or greater than symbol. And you can do that with a quick test point. You can see, all right, pick a point on this side of what I just graphed, plug it in. Does it work for the inequality? If it does, great. That's the side you shade. If it doesn't, then you shade the opposite side. Once you pinpoint a point that works, then every other point on that same side will work, and no points on the other side will work. So you can do the shading, feel confident, and then have your picture of your solutions. So I wanted to show you by hand how to do some of these, and then I also wanted to show you on the graphing calculator how to handle some of these. The graphing calculator isn't perfect. You do need to know what you're doing to interpret what the graphing calculator is saying in some cases. So just to warn you, but you do need to also know how to do it by hand and know what's happening with these problems. All right, so let's start out with a linear inequality. Actually, let's do a linear inequality first. Bring up my pen here. Let's say we have something like x is less than 3 plus 2y. Okay, I can see pretty quickly that this is going to be involve a line, because there's an x and a y. They're in separate terms, and there's no crazy exponents on them. It's just x to the first and y to the first. And I can rewrite this so that it's in the slope-intercept form of a line. I can solve for y. Let's see, I'm going to go ahead and subtract 3 from both sides. And then I'm going to divide by 2 on both sides. And for those of you who aren't comfortable with having y over there on the right, you could pick this up and flip it around. Put y first. Notice the mouth of the sign is open to the y. Let's keep the mouth open to the y because I'm not changing the problem. I'm just flipping it around to make myself more comfortable having the y first instead of second. And if you really want to break this apart to see the slope-intercept form, you can go ahead and divide each term of the numerator by 2. And then you can see the slope and the y-intercept. Okay, so essentially you have a line here, except instead of an equals to, you have a greater than. So you're going to go ahead and graph the line, and that's going to be your border. Okay, so in this one, the slope is 1/2. Yeah, let me just kind of write real quickly. The border is a line. Slope is 1/2. Y-intercept is at -3/2. So let's see, 0, -3/2 would -1.5 would be right here. And you can go up 1 over 2 up 1 over 2 for as much as you want, and that'll give you some other points that are on that line. So 2 comma negative 1/2 would be another point on that line. 4 comma positive 1/2 would be another point. 6 comma 1.5 would be another point, and so on. Now, since it's a greater than, you're going to use a dashed line to connect the dots. If it had been greater than equal to or less than equal to, you'd use a solid line. But since it's greater than, or if it was less than, no equals to, you'd use dashed. And you can extend it as far as you want. Doesn't really matter how far you go, but there you go. There it is. There's the border. So all of these points, if you plug those ordered pairs into the problem, would make the two sides equal. But notice that the original problem has no equals, so we used a dashed to say, well, those points aren't actually included. But we needed the border to know what points are included. We're going to take a point on either side of that line, and we're going to use it as a test point. I always like 0, 0 if it's available, because it's easy, but if it's on your border, you can't use it. Like any points on the border, you're not using for a test point, because you're trying to see which side of the border has the solutions for this inequality sign. So using the border is not going to help. So 0, 0 is not on my line, so that's good. I can use it. And I can go into, if I want to, I can go into the original inequality. I can use any of those versions up there of the inequality, but I like going to the original just to make sure I avoid any errors or compounding any errors. You plug it in and see what happens. If you end up with a true statement, which we do here, then that's the side you're going to shade. Because if 0, 0 works, then every other point on this side of that line will work. Every other point on this side will satisfy that inequality. Ooh, oh, I'm horrible at the coloring, aren't I? I'm trying to use this tablet and color. Let me erase that little section there that went out. Sorry about that. But yeah, you just do your best shading that in. Now in my math lab, it's usually set up to where you just click the side you want to shade, and it goes ahead and shades it for you. But you have to know which side that is. So you got to make sure you've done the problem correctly so that you can get the correct side shaded. And guess what, folks? If you're using a graphing calculator, especially an older model like TI-83, again, you have to know which side to shade because the calculator doesn't figure it out for you. Some of the newer models can figure it out, but not everybody's got those newer models. So you're going to need to know what you're doing. If you have an older TI-83 or even an older TI-84, you've got to know what to tell it. But there you go. There's the solution set to that inequality. All right, so speaking of graphing calculators, I want to show you how to put this in and how to use the calculator to get the same result. As always, in the calculator, you have to have y equals. You can't have it in the form that the problem was originally presented, because you have to have solve for y in order to put it in. And I know this says equals, but don't worry. Let's go ahead and do this. We're going to put in the 1/2 x minus 3/2. And my calculator, since I'm having to do it this way, it does not show the dash line. So I have to know it should be a dash line because of this symbol here. But I also have to know where to shade. Okay, I can do the test point, but let me let you on a little secret. You don't necessarily have to use a test point. If you have your inequality solved for y, and if you have y over here on the left side, Your inequality sign will tell you where you're shading. If you have y greater than or y greater than equal to, you know you're shading above whatever your border is. If you have y less than or y less than or equal to, you know you're shading below whatever your border is. So in our case, we have greater than, so we're shading above. So I'm going to come over here to the left of the y1, and I'm going to start hitting enter. Okay, that thickens my line, and there we go. Here's my shading. That selection will shade above my border. If I kept going, the next selection would shade below. So again, the calculator's not telling me which one to pick. I have to figure it out. And if you go too far, just keep clicking enter. It'll start over. And there we are again. So now you see it on the graphing calculator, how to do it. So you've got your border, and then you've got your shading. So just wanted to warn you that like some of the newer calculators, you can go ahead and put in the inequality sign, and it'll do this. It'll figure it out for you. But not all of them do that. So just to let you know that like older models, most of your older graphing calculators will probably do it like this. All right, so there you have it. That's just a basic linear inequality. So let's do a nonlinear one next. Those are fun. So nonlinear is the same kind of concepts, but just you're not doing a line this time. Y is greater than, oh, thankfully they went ahead and solved it for y. Y is greater than or equal to 2 times x plus 3 squared, quantity squared, minus 1. So immediately I see that this is not a line. I have that squaring there where the x is present. But looking at it, I recognize it. We talked about parabolas in the past, and we talked about parabolas having this form. Y equals a times x minus h squared plus k, where hk is the vertex. So it's a quadratic. You should write down the words. That way later you'll see it in the notes. Remember, you can go ahead and download this slideshow. I update it each week as I'm doing the recording so that you see the slides with the notes. So we're gonna end up with a parabola for our graph. Hk is the vertex as long as it's x minus h quantity squared plus k. The a tells you if the a is greater than 0, the parabola is going to hold water. If the a is less than 0, the parabola is going to dump out water. So a is positive, it's concave up. A is negative, it's concave down. So knowing all that, it'll help us with our graphing of our parabola. So for the equals to part, we're going to graph the parabola, and since there is an equals to right there, we're going to use a solid border. All right. Yes. So let's see. So my vertex in this problem is -3, -1. So there's opposite sign of whatever's in the parentheses, same sign as what's outside. -3, 1, 2, 3, -1. Here's the vertex. This parabola is going to be concave up. Get a couple more points. Let me do a quick XY table just to make sure I get the shape quite right. Let's plug in -2. If I plug in -2, -2 plus 3 is 1, 1 squared is 1, times 2 is 2, minus 1 is 1. So -2, 1. But remember, there's a line of symmetry going through the vertex, so that tells me that -4, 1 will be another point. If I plug in -1 plus 3 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 1 is 7. That's what tells me at -5, comma 7 will be a point. And if you want to do more, you can. I'm not sure you really need more than that right now. You can plug in 0, 9, 18. Oh, that's going to be way off of my grid. I'm not even going to worry about it. So that's enough points now to see how skinny or how fat or whatever your parabola is. Because remember, with that 2 out front here, with a being 2, you know, you're being stretched by a factor of 2. You can also use your rules of shifting and reflecting and all that if you wanted. You don't have to do it the way I just did it. Like if you want to use your rules of shifting, reflecting, etc., you can start with y equals x squared. The x plus 3 tells you you're shifting 3 to the left. 1, 2, 3. The times 2 tells you you're stretching it vertically by a factor of 2. And then the -1 tells you you're shifting it down 1. So just following your vertex would go left 3, down 1. Here it is. And then these 2 points would normally be here and here, but timesing by 2 stretches by a factor of 2. And then these got stretched by a factor of 2. So anyway, so there's that. All right, so solid drawing. Here's our parabola. Let's do a test point. Now you could do 0, 0 again if you want. It's not on the border. So going back to the original problem, is 0 greater than or equal to, I'm really testing the greater than because I know it's not equals to. 2 times 0 plus 3 quantity squared minus 1. So is 0 greater than 9, 18, 17? No, that's false. So we're not going to shade the side with 0, 0. Rather, we're going to shade the side that does not have 0, 0. So in the case of this parabola, we're shading inside of here. Because with this parabola, you've got either the cup part, that's one side, or you've got the outside of the cup part. So if you're doing this on graph paper and stuff, you can get all fancy with colored pencils or something if you want. But just keep in mind, you know, on my math lab, you're gonna just be clicking where to shade. Or it's gonna be multiple choice where it asks, okay, which is the correct graph? Like that. So as you extend your parabola, all of the space inside of here is shaded. And that means you could pick any point you want inside this parabola in the cup, any point you want, and that will work in the original inequality. Pick any point outside the parabola and it won't work. So there you go. Okay, what next? Went on and talked about the steps here again. You're not going to just be graphing single inequalities. You're also going to have systems where you have 2 or more inequalities to graph, and then you're trying to find the final solutions. They give you a system of inequalities. Ultimately, you're trying to see where do the solutions overlap. And in that case, you just, on my math lab, you're just going to shade the overlap part. Or if you're doing it by hand with pencils and stuff, you can use different colors and then have a color key off to the side, or you can do like light, light, and then dark, you know, if you wanted to do it with just one pencil or a pen or something. So, but you do have to figure out where things overlap. Oh, before we do though, I was going to show you this one on the calculator. Let me do that. Let me quickly go to the calculator and show you how that one's done. Let's see here. Let's clear out. Let's start over. Start fresh. Do 2 parentheses x plus 3 parentheses squared minus 1. Okay, you hit graph. There's your parabola. But then you know that since it's y greater than or equal to, your little shortcut, you don't have to use a test point. Y greater than means you shade up above the border. So if this is your border, going up from it is in here. So back to this, go over, enter, enter, shading up, graph, voila. So there it is with the shading. Okay, so I wanted to show you that. Going back to graphical solutions, let's with a system, let's do a system, and I'll show you how that works. All right, original system, we got x plus y is less than or equal to 4. Tell you what, you know what? I'm going to do them in different colors, and at the end darken in the final result. So I'm going to do green. So x plus y is less than or equal to 4. So let's do that one first. Let's see, y is less than or equal to negative x plus 4. Slope is negative 1, or negative 1 over 1. Y-intercept is at 0, 4. We're going to use a solid line because it's y less than or equal to. So 1, 2, 3, 4. Here's the y-intercept. Negative down 1 over 1, down 1 over 1, down 1 over 1, etc. Not quite sure yet how far this has to stretch because I haven't graphed the other line yet. So for now, I'll just do that. Y less than equal to, I can see that I'm going to shade below the line. If you want to do a test point, you can. But I know the shading is going to be in here. All right. Now I'm not going to commit to doing too much more until I do the other equation that's in this system. What should I use? How about red? Holiday season's about on us. Red and green, holiday-ish colors. All right, x minus 2y is greater than or equal to 6. And for those of you who are watching this when it's not the holiday season, I apologize, but right now it is. Okay, so negative 2y is greater than or equal to negative x plus 6. Ooh, divide both sides by negative 2. Remember, if you're going to divide or multiply both sides of an inequality by a negative number, you have to flip that inequality sign. Don't forget that. Let's see. Negative 1 over negative 2 will be just 1/2 x. Plus 6 over negative 2 will be minus 3. Okay, so slope is 1/2. Y-intercept is at 0, negative 3. 3, 1, 1, 2, 1, 1, 2, 1, 1, 2. Okay. Sometimes I'm just, when I pause, sometimes I'm mentally checking my work, kind of looking at it, making sure everything works before I go too far. So in case you wonder sometimes while I'm briefly pausing. All right, and another one, this is going to be a solid line. This is another one where we're going to shade below. All right, so I can see where this one's heading. So let me go ahead and extend a little bit. 1, 1, 2, and then 1, 1, 2, 1, 1, 2. All right, go ahead and connect the dots on this one. And I know I'm going to shade this one below. scribbly. Prefer using pencils and stuff for this so that I can just, it looks neater, but whatever. You guys get the idea, right? All right, let me switch back my color so I can finish extending the other one and see exactly where things are going. I think it was that one, right? All right, so the other one, maybe it was the darker color. Okay, let me switch color again. There we go. Okay, if extend it, see exactly where everything collides. And that's what you want to do in a system. You want to see where they overlap each other, where they crisscross. Oh man, I just said crisscross and immediately these song lyrics pop in my head. That happens sometimes when I'm talking. So if I ever also pause when I'm talking, it's something like that's going on. My son's class at school just had a dance and they were doing that Casper slide, crisscross. So immediately I was, thinking about that as I'm trying to extend this line. Sorry. No wonder I get anything done with the way my head just everywhere sometimes. Let's see, there's my, let's try to find my mouse thing there. There we go. My pen disappeared from me a little while. Coloring. Speaking of like being a little bit ADHD, I hear coloring and it's a big trend right now. They're saying that coloring for adults is as good as meditation. And I believe it. Nothing like breaking out a coloring book in my 96 box of crayons and coloring for a while. Escape. All's right with the world. I mean, that's what I'll ask for Christmas is a coloring book. Anyways. All right. Because Lord knows I need practice. Because look at this. This is awful. Guess I didn't practice enough as a kid. Okay. So there we go. Here's our two inequalities. We're seeing where they overlap. So the red and green together is where they overlap. So we can see it because I use different colors. If you're using light and light, you'll see where it gets darker. But let me change my ink color to black. So right here in this overlap, where it's both red and green, that's my solution set. That's the space where you could pick a point here and it will work in both x plus y is less than or equal to 4 and in x minus 2y is greater than or equal to 6. So it's going to work in both of those places at the same time. So what do you think about that? So I'm just using black now. It's kind of hideous, but anyways, darkening it in, you can see exactly where the solution set is supposed to be. And since it's an and, let's see, the red line is solid and it's going through the green part. So in this case, this part of the red line is part of the solution. Now, if the line was dashed, it wouldn't be part of the solution because with a system like this, they both have to be included. And the green line is solid and going through the red shading part. That is also part of the solution, as long as it points from both are included. But this part of the red line doesn't share anything with the green. This part of the green line doesn't share anything with the red, so they're not part of the solution. The system, you're trying to see what works in both x plus y less than or equal to 4 and x minus 2y greater than or equal to 6 at the same time. So there it is. Okay, let's do one more example. This time, let's have one where it's not all both lines. One more example. This one of the inequalities is a line. The other inequality involves a parabola. So you'll get to see nonlinear version of a system. And again, let me do different colors. So let me erase that. Let's change colors. I used red earlier. Let's use red again. 4x minus 3y is less than or equal to 12. So let's see, negative 3y So less than or equal to negative 4x plus 12. Y, flip the sign, greater than or equal to, because I'm dividing both sides by negative 3. Oh, that's what I get for thinking about 3 while I'm trying to write 12. That's a 2 there. Ooh. So y is greater than or equal to 4/3 x minus 4. So we got 0, negative 4, then 4/3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. That's a solid line. Solid line, shade above. So we know we're going to be shading up here. Okay, let me switch colors, get the other one. I don't want to use blue this time. Y is less than or equal to x squared. Dealing with a parabola. And we're doing solid. And then this one you're going to shade below. Y equals x squared would be a parabola. Just like that. Okay, so we're shading below because it's y less than, so that would be all out here, outside. Well, for the line, let me do my colors again. The line, I can go ahead and extend it. Put my little arrows. I know the line's being shaded all out here, up here. Okay, so the commonality would be everywhere that is red and blue at the same time. So that would be out here until you get to the line. So outside the parabola, but above the line at the same time. So that's all of this space here. So you pick any points in that blackened area, and you are going to have a point that'll work in both inequalities at the same time. Let's stick those in the calculator, show what it looks like. Okay, first one, let's put that in the calculator. Y is less than or equal to negative x plus 4. And then we know we're shading below. All right, and then the next one, we got 1/2 x minus 3. And that one we know we're shading below also. So when you hit graph, there it is. You see the same thing, except instead of colors, you see the shading going in different directions. And where you have that checkerboard, or I guess gingham pattern, that's where the overlap is. That's where I shaded black before. So on the calculator now you can see where the overlap is. clear that out. Let's try the next one. A minute. It's like I'm asking my computer to do too much all at once. Okay, so that one. I've got 4/3 x minus 4. And that one was shading above. Okay. And for the next one was x squared. And that one was shading below. Hit graph. And when I do, we'll see it. There it is. You see the parabola, and you see what my parabola had been blue with blue shading. That's the shading that's horizontal. Then my line had been red with the red shading. That's the shading that's vertical. And then you can see that checkerboard pattern all through here, under the parabola, but still above the line. So that's your common region. Okay, so there you go. There's your calculator version, and there's the hand version. Make sure you know how to do both. But again, too, for the calculator version, you still have to be aware of what's happening with the inequalities in order to know whether to shade above or below and so forth. All right, well, thank you for joining us, and I hope to see you again soon.